Good afternoon. I'm going to speak to you today about water supply for humanitarian and for development assistance in populations in need. Essentially, the two main components are water quantity and water quality. Those are the two main challenges that we're going to look at today, and underlying all of those would be the issue of access. But in terms of water quantity needs, water is essential for life. We need it for drinking, cleaning, and food preparation. The WHO minimum for all of this is 20 liters per day per person. That's the minimum, and that minimum can only be maintained for a few days before we start moving into a negative water consumption budget per person. We also need water for personal hygiene and for washing clothes, not just to be clean, but prevent transmission of disease. For medical purposes, we need water for surgery. That can be as much as 100 liters per intervention. And for other productive activities such as gardening or even managing smaller, larger stock. Cattle, for example, require up to 30 liters per animal per day. And all of these elements are access to external factors such as time, distance, cost, investment, and social factors such as conflict and ownership. In terms of water quality, what constitutes good water quality? The elements are that there is no biological contamination. There should be a low concentration of toxic products, and water should be relatively clear or have a low turbidity. It should not be too salty or mineralized, and that's not always occurring in terms of commercial or industrial activity. There are many situations where water is very salty due to the natural environment around it, because water, as it moves slower and slower, tends to take up the chemical composition of the geology around it. So if you have certain soil types or certain rock types in which water is contained for long periods of time, it will become mineralized. Finally, color, odor, and taste need to be acceptable. And this is not a biological, a toxic, or a mineral characteristic. What this is largely social and cultural. There are many areas where people will not drink very clear water because it's normally appearing in their environment as water which has been poisoned and in which nothing can live. Elements of water quantity and quality are displayed in the water life cycle. If we look at the diagram in front of us, you can see water moving around the planet and inside the planet in the different states of solid, liquid, and gases. Water from the surface of the earth evaporates or is transpirated from surface cover vegetation into the air, and in that atmosphere it becomes water vapor. Usually we see that as clouds, but it's not always visible as clouds. When we have condensation of water in the gaseous state, and we have elements of particles which allow water droplets to condense and become heavy, they fall to the earth as precipitation, usually in the form of rain, but also in the form of snow and sometimes ice. Water, as it moves through the cycle, has different rates of movement. Surface water has a smaller and tighter, faster cycle in the water life cycle overall. Rain and precipitation flows quickly downhill and collects in rivers, lakes, and ponds, and is evaporated immediately once it is exposed again to the sun. Access to the surface water is usually seasonal, changing between summers and winters in the northern colder climates, where water usually freezes and changes its character from a liquid to a solid, to the hotter climates, where water in the dry seasons is not acceptable because the evaporation exceeds the precipitation. Groundwater can be difficult to access, but it can be a better quality as well because it's not exposed to surface contamination from biological or commercial or industrial activity. Having said that, we must remember that water in the subsurface can still be of bad quality if it is heavily mineralized due to the surrounding geology. Finally, in terms of recharge, water in the ground moves much more slowly than surface water. Thus, its rate of movement in the water cycle is slower. Recharge is slower because of infiltration and geological conditions, varies from place to place. And water just moves much more slowly into the subsurface before it can be accessed. One of the challenges to remember in terms of accessing water in groundwater situations is that if your outtake exceeds the recharge, you very quickly move into a negative water budget, which cannot be replaced. Finally, in terms of precipitation and its characteristics are also seasonal, changing from rain to snow in the colder climates. Also can be found as fog moving along coastal zones, and that is also seasonally impacted. In terms of precipitation also, there are elements of storage which are different from groundwater and different from surface water. We've already mentioned that surface water cycle is much more quicker in terms of its storage time on the surface than it is as groundwater. But storage time in terms of precipitation, while the rain might evaporate quickly, snow generally tends to remain for a complete winter season. And in certain environments of high altitude and in northern latitudes, we find precipitation being stored as highly compressed snow, which becomes ice and eventually glaciers. And there the storage can last from hundreds to thousands of years. In terms of water access, we have different types of intake options. And two I'll describe here are linked to low technology and higher technology. In the lower technology end of scale, we're looking at the very simple hand-dug wells, which is the next step in terms of water management beyond quite simply taking water out of the surface of the stream or lakes or ponds. Hand-dug wells require a very low amount of tools and technical input. It's simply a hole dug into the ground. And water is abstracted from the hand-dug well with buckets or very simple hand pumps. In terms of hand-dug wells, we have limitations in terms of the depth that you can excavate a hand-dug well, depending on the soil conditions, but also in terms of safety. Generally around 30 meters is about the maximum option you want to consider, not just for the safety of the excavation team in terms of stability, but also at 30 meters of depth, you're having difficulties with access to oxygen, pumps may be required, and we may be getting exposed to noxious gases as well. In terms of more advanced technology, boreholes are often considered as an option to hand pumps. They consist of a very small diameter hole excavated in the ground, usually by a mechanical machine, but sometimes by hand drilling equipment as well. And the interior structure consists of a tube, or what we call as a casing, which is surrounded by materials which helps to filter the water. Benefits of the borehole is that it can be more easily protected than a hand-dug well, can be covered to prevent surface contamination. That is less evident with hand-dug wells. Usually water is extracted from boreholes by pumps. They can be manual hand pumps, or they can be engine-driven pumps, which can be run by diesel engines and motors, solar pumps, and wind pumps. Boreholes range in capacity from 50 meters up to 200 meters, and the depth of the borehole is what defines the technology to be applied for the outtake. Most hand pumps can function up to 30 meters and sometimes 50 meters. But 50 meters is extremely difficult, requires a hand pump of a certain design and construction, which is under heavy stress more prone to breakdown than more shallower hand-dug wells. Also, in terms of maintenance, shallow wells are easier to maintain with low-level technology, whereas much deeper boreholes require extra tools and special design equipment to lift out the materials for treatment after a breakdown. Water access options also include spring capture. Here we see a diagram of groundwater which changes its character physically just by the nature of the geology around it. And as you see in the diagram, certain formations come to the surface, and when the water reaches the end of that formation, it reaches to the surface itself, often in the form of a spring. Usually these springs run downhill. Springs then can be captured, as we see in this image here, where we protect the source of the spring and we set up an outtake. What's important, one, is to protect the source at its point where it comes to the surface, so as to minimize contamination, but also to maintain the ongoing flow, so the downstream characteristic of the spring is not disturbed. Water distribution is also important. It's not just getting water into every single household by plumbing or piping or hoses or taps in each living environment. Sometimes in many difficult circumstances, or just in poor economic circumstances, people have to collectively share access points. If we look at classic water distribution for displaced populations, we try and install one tap or robinet for 200 persons. That's an absolute maximum, because that also means still people standing in line for some hours a day just to get access to a minimum of water. Additional requirements in terms of access to water are the containers that we use. And containers are used for two activities linked to water. One is for collection and transport, and the other one is for storage. In all cases, all containers should be regularly treated with a light chlorine solution to make sure that they are free of contamination. The design of the container optimally should be a container that has a very narrow opening and should have a lid that can be closed. That's for transport and also for storage in the domestic environment as the household. What's important to keep in mind here is that once the water leaves the ground, as clean as it may be, it can easily become contaminated in the collection process, the transmission or transport process, and in the storage process. All these elements need to be carefully managed and the containers carefully kept clean. So in summary, what we need to remember that there is more to access to water than just elements of plumbing and piping and hosing and a hole in the ground. There are environmental conditions which need to be observed and dealt with, and also the concepts of quantity and quality, which can be affected by environmental conditions, by transport conditions, and by storage conditions. Water of bad quality, which is accessible for everybody, is not access to water. Water of low quantity and good quality may not be enough either. So all of these elements need to be considered. Thank you.